So in all the examples we've been doing on finding the greatest common factor, essentially we've been using the distributive property. So we know that the distributive property allows us to take a factor and multiply it to every member of the group that's being added or subtracted. And the distributive property works both ways. You can multiply, or I like to say unmultiply. So if we consider, if we have AB plus AC, we can essentially unmultiply that by writing it as the GCF as A being multiplied to B plus C. And then analogous to that, if we have AB minus AC, we can rewrite that as the GCF of A being multiplied to B minus C. Okay, so let's just remember that as we are looking at some of these additional factoring questions. So let's take a look. All right, so on the left side, if we consider the term 3xy and the term 2y, the GCF, the greatest common factor between those two terms, is just y. Right, that's our GCF. So I'm going to factor that, then I'm going to rewrite it as y, and that's going to be multiplied to, right? And if I want to find what my second factor is, I can divide the first term by y and the second term by y, and that's going to give me 3x plus 2. So there we go. That's the result of factoring out our GCF. Now compare what I just did here on the left to what we have here on the right. A similar example, but instead of 3xy, we have 3x and then a factor x plus 7. And the next one, we have 2 multiplied to a factor of x plus 7. So we can see that our common factor is the x plus 7. So there's our GCF. Our GCF is actually a binomial, x plus 7. I'm going to put it in parentheses just for emphasis, but it's actually not necessary if you're just writing the GCF. Okay, so if I factor this, instead of factoring out a y like I did in the first example, this time I'm factoring out the x plus 7. All right, so if I want to get my second factor here, if I divide 3x times the x plus 7 by the x plus 7, and then that's going to leave 3x. And then if I divide the 2 times the quantity x plus 7 by the quantity x plus 7, that's going to leave plus 2. So as you can see here, these two examples are similar. Let's try some more of these. All right, let's consider the example 3x multiplied to the quantity 2x plus 1 and 7 multiplied to the quantity 2x plus 1. So let's think about, okay, what is our GCF? Well, 2x plus 1 is the GCF. I'm going to put it in parentheses just for emphasis. There's our GCF. All right, so if we're given the expression, which is similar to what we had in the beginning, 3x times the quantity 2x plus 1 minus 7 times the quantity 2x plus 1, I can see the GCF is 2x plus 1. So I'm going to factor that out. That's my first factor. So if I divide the first part by the 2x plus 1. I'm left with 3x. And if I divide the second part by the 2x plus 1, that leaves us with the minus 7. And there we go. We have completely factored this. So let's take a look at part D. Another example we have here, 3u parentheses u plus 9 and the term u plus 9. So our GCF here, u plus 9. So if we consider this as some sort of expression, this time I have 3u times the quantity u plus 9 minus the quantity u plus 9. Now, you want to be careful here. I like to think about if I don't have a coefficient outside of these parentheses, then assume the 1. Okay, if it helps to write it in like I wrote it in, I would recommend you do that. But we're going to factor this, so we'll factor out our GCF of the u plus 9. And then I'm going to divide the first part by the u plus 9. So that gives me 3u. Divide the second part by the u plus 9. So that leaves me with minus 1. And there we are factoring. Okay. All right, so let's take a look at one more example. All right, so I like this example because it just allows us to pause and not be so automatic. So we have here 2xw times the quantity x plus 3 and 5x times the quantity x plus 3. So you might be tempted to say the GCF is just the quantity x plus 3, but be careful because there's more than that. You have a common factor of x and the x plus 3. So our GCF is x times the quantity x plus 3. All right, so let's not be so automatic that we miss the point of it, which is to find the greatest common factor. And we don't want to miss any common factors. So if we consider this as an expression, 2xw times the quantity x plus 3 plus 5x times the quantity x plus 3. If our GCF is x times the x plus 3, right, then I'm going to divide by that in the first part. And so the result is going to be 2w plus, and then the second part, divide by x times the x plus 3. That leaves us with 5. And there we are, completely factored.